The first one down. Undergrounding. Yeah.
Testing, you hear me? All right. Welcome to our session on wildfire. Want to let's bring the energy in. I think it's been consistent in the other sessions. A lot of energy, a lot of talk, which is great. A lot of what happens. I've reminded myself, I haven't been to a conference in so long, right? Pandemic kind of wiped out conferences for a while in person. And we realized it's the conversations that happen in the margins that are really where the value is. So we want to get to that conversation here too. Before we dive in, just want to reiterate, you probably had this in other sessions. From a safety perspective, we've got doors at the front, door here at the back. If we need to evacuate the building, you just head straight out, all the way out to the, what is it, Camino San Ramon. Camino Ramon, thank you. So we'll all walk out there just away from the building. So that's really the evacuation procedure. Thank you for coming to our session and we look forward to the conversation today on situational awareness and eliminating ignitions relative to wildfire risk. My name is John Eric Tallman. I run a team on risk and data analytics that produces a lot of predictive models for wildfire. And I want to introduce James Tuccillo, who's going to talk about his a little bit, and then we'll get into our topics.
Good afternoon. My name is James Tuccillo. I'm a distribution engineering manager, and I also support all of our distribution protection strategies and engineering as well. And I'll be talking a little bit more about the work we're doing to reduce the amount of ignitions related to power line system faults.
All right, thanks. You going to run that? All right, cool. All right, we're going to talk about a number of items under this category. And PG&E, you heard about our stand that we're committed to that catastrophic wildfires will stop. And that's not just PG&E related, as you heard earlier. So we're looking at technologies and collaborations with others, both in this session and the next session I'll mention. We take a multi-layered approach. The items here in orange are the ones that we will be covering today in this session. The next session will actually be covering the ones in blue that are more related to vegetation and that aspect of forestry within wildfire risk. Let's go to the next one. So first I want to talk about our inspection processes and tools and how we pull that data into the whole series of diagnosing what we found and taking action, all with the intent of building a more robust and resilient grid to serve. You heard about the demands that are going to be made on the grid in the future. We're looking to that saying, okay, what kind of grid resiliency, what type of grid reliability is needed for that? And what kind of tools do we need to be able to put that in place? So we currently use a wide range of data collection and inspection and technologies to pull that data into our processes. But there's a lot of room there for improvement when you look at the cost and resources of collecting that data, processing that data, making decisions on that data. So we want to talk about what we think of some of those opportunities. There are some of the key areas we think outlined here on this slide. One, PG&E has a rather large set of assets within the electric grid, the service territory we cover. So we look at, yes, there's a technology. Can we scale it? How cost effective is it? What does it take to get into the hands or the vehicles or whatever it is that's going out and visiting and looking at locations and then bringing that data back? When we look at how we assess the condition of an asset today, when we do an inspection, we're using tools and processes that have proven well. I'm getting one of these. Does that mean you can't hear me? Okay, thank you. I just want to make sure. That bring back the data that with our past practices are what we've needed to maintain the grid. But when we look at something, for example, like a pole, and we have to send an inspector out with a tablet that might look at it and say, okay, I'm going to record what I think is the condition of this asset. We are looking at the need to be able to better understand what is actually the remaining life of that asset. Can we understand the interior condition of that asset, whether it be the pole or the transformer, either in the structure or electrical, and I'll talk a little bit more about that. Once we know that condition, can we determine how long do we have until it might fail? It's one thing to say we think there's 50% life left on this pole. The other thing is, okay, given its location and the stresses and the loading on it, How long do we have before we should take care of that so we can avoid a problem? All of this data, the challenge then is to bring it into our processes. And sometimes that is a rather large challenge. I'll give you an example. We've been very aggressive in doing LiDAR surveys of a lot of our system. And that's amazing data, especially for the modeling team that I run. And I know there's other teams that really enjoy that data. It takes a long time to get LiDAR data into the point and processed, and you can use it. Almost to the point that sometimes I say, okay, this tells me the condition of the trees around this line, but how much have the trees grown since we took this data? So this is a challenge. This is an area ripe for improvement, we believe, is being able to pull data in. And then with all of this, you're automating the collection. Are we automating the analysis? I think it was either Patty or Quinn or somebody mentioned earlier this morning, and I thought it was a good point that triggered with me, was we have skilled people working on all these processes, but often part of the job is processing the data, preparing the data, and are we really focusing their work more sufficiently on where their skill set is? So if you've got an engineer looking at the condition of something, how much time do they spend prepping and getting the view right, and then applying their knowledge to make a decision? So let's go to the next slide. Last point I want to do is there's kind of two general areas here. There are structural assets that we're looking to understand and for these improvements, and then there's the electrical assets. And I think I highlighted one of those when we were talking about internal condition. There's the internal condition of a pole. What would it take to be able to inspect, scan, or what have you, and understand the internal condition of a pole, as opposed to looking at a pole-mounted transformer? What would it take to understand the internal condition of that asset? Two different types of assets that we're looking to improve on. So that's generally the area I wanted to tee that up to. I look forward to our conversations on that. I want to give some time to James to talk about another area that we worked on. And actually, Patty mentioned this on EPSS. So that's an area where we think our stand is to remove catastrophic wildfire. And with that, we can't be satisfied with the improvements we've made. So we want to give some time to talk about that.
Thanks, John Eric. And I recognize this is after lunch. Everyone's probably a little bit sleepy, so hope everyone has their coffee in hand or caffeine of choice and is ready to dive into maybe a little bit of electrical engineering 101. So as John Eric mentioned, reducing our risk of catastrophic wildfire is definitely a multifaceted effort. And one thing that we are doing right now, at this point, while we wait for undergrounding, asset management, and maintenance enhancements, is to tune our protection settings and make adjustments to the strategies that we apply on our protective devices on both transmission and distribution to minimize the chance of arcing should a fault occur on the power system. This graphic here is a bit basic, but really shows a very simplified view of the distribution system. And what I want to communicate today is a couple different areas where we need partnership, we need innovation to continue to enhance this program to be as effective as possible. So the first element of this graphic here shows what happens, for example, when a branch falls into the line. One of the biggest areas for innovation and enhancement right now in our power system protection strategy is to be able to detect faults that occur on the system that actually look so much like load that they're undetectable to our relays and control system. So by applying new detection algorithms and methods to be able to sense very, very minor disturbances on the system and be able to take action to trip and de-energize the system, we can prevent conditions like this from actually evolving into higher current, higher energy faults on the system that could rain sparks down or create flammable sources that could fall to the floor of the forest or onto the grasslands and start a fire. The second item, which is really important also, is that by enhancing the way this protection works, we have to rely on relays and equipment that aren't everywhere. So kind of nerding out here a little bit, the power system, for those that aren't electrical engineers or protection engineers, is very similar to how your main panel works in your home or your business, where you have kind of a main breaker and then you have different branches that feed the different rooms of your house. And typically what we have is, instead of breakers feeding each branch of the circuit, we have fuse protection. And fuse protection is great because it's simple, it's easy to maintain, and it works effectively. However, it's kind of a unintelligent solution. It doesn't have the ability to add algorithms or machine learning and so forth. So what we've done is we've actually created zones of protection that are larger than we would normally have without our enhanced power line safety setting. So by allowing us to install lower cost, smart protective devices on these downstream tap lines and laterals, we can restore the sectionalizing of our system to the furthest levels to be able to both provide this enhanced protection, but also minimize the impact of outages if they do occur. The other point there is we, as part of our program, really focus on reducing we call the clearing time, or the response time of the relays, to provide the most quick response to fault conditions to prevent the arcing that occurs, the sparks from flying. And some of our devices can operate very fast, 2-3 cycles. We have an objective of clearing faults under 100 milliseconds currently, but we need new technologies, new protective equipment that could clear faults even faster than 100 milliseconds. So we're looking forward to partnership and ideas around different types of smart relaying protective devices that can interrupt faults in perhaps 1 cycle or less. The other point here, which is actually becoming increasingly more important with undergrounding, is that we continue to apply protection in a way that, as we build out the underground system in these rural areas, we don't have this level of sensitive protection overreaching into the underground component. Underground components are very reliable when they're commissioned, but we know that problems will occur. And the idea of a complicated, vast underground system with very sensitive protection keeps me up at night. So we want to be able to install communication systems, control strategies that allow us to block this level of protection if a problem, for example, is sensed in the new underground parts of this rural distribution system. And lastly, what's very important also to me is that we continue to maintain a level of reliability that our customers expect from us. And when we all can see, when we enhance our protection, we create more sensitivity, we are more susceptible to small disturbances on the system, creating outages and problems. So in order to reduce that impact, we want to help integrate more data, and we'll talk about that a little bit in the next slide, to where we can find the faults on the system quicker and with greater ease. Some of these lines are in very remote areas. It takes, in some cases, hours to patrol and drive the lines out. And so utilizing sensors and other kind of non-traditional detection methods will help us create a faster response when faults do occur on the system. Okay, so this is kind of just a wrap-up summary, and then we'll get to some of the Q&A here. 3 main topics here that are covered. One is continuous asset monitoring. As John Eric mentioned, we can't be out with our eyes visually inspecting this equipment all year long. Problems can happen mid-year, different times when our risk is high. So we need better visibility in both the electrical and the physical network elements of our system. We're open to any innovation and ideas regarding sensing-based monitoring, physical monitoring with, for example, sensors on poles to detect leaning, to detect motion of conductors slapping together, those kind of items. Camera-based sensors, those are all on the table. The second part, I kind of mentioned fault detection. So looking at new ways to find problems, and I'll even extend this into the underground system, because I know, right, the underground system will have its challenges eventually. if not right at the beginning of the installation. So we want to make sure that our system's set up to be able to find problems. Examples are running communication with the underground facilities. I think you probably heard in the last session the idea of installing telecommunications fiber for kind of novel detection of fault conditions in those rural underground systems. And then finally, when an ignition does occur, knowing about it as quickly as possible, leveraging AMI, line sensors, everything is on the table to be able to detect when a problem does occur. If we can get our personnel and our emergency services on site, if an ignition does occur faster, we have a much greater chance of containing that event. So these are some monitoring and technology strategies that we look at in conjunction with our undergrounding program, with our enhanced power line safety setting. And these holistically will help ensure that we can make that stand a reality, that catastrophic wildfire shall stop. So I'll stop there and open it up for questions. We'll take 2 in the room and then go to online. All right, how about the gentleman in the middle? Since I think you were in the last session too, and you didn't. All right.
James Wingate, USA North 811. Are you considering, as you plan to bury the new cable, are you going to take it, do anything differently in regards to locating it in the future? As far as normally it's just burying conduit and then to locate it is connected to transformer. Are you going to do marker balls or something, other technology that you haven't before for these very rural areas to protect it going forward? Have you thought about that one?
Yeah, I think that question's probably best directed to the panel from the previous presentation.
Got it.
But I would say things like running communications with the underground, most assuredly will be part of the strategy for improved fault location.
Just generally locating assets once they've been installed, great area for improvement. So.
Hey, I'm Josh from Google X. I'm curious, you mentioned earlier that the LiDAR data that you're collecting takes forever to process. And I was wondering if you could talk a little bit more about what you do with that LiDAR data. Like, what format does it stay in? What format does it move into? Is that where the processing time goes? Could you kind of describe what that challenge is a little more?
I'm a little out of my depth on this one. I'm a user of the data. I know there's a lot of post-processing it because it's a very raw data set, and then getting it to, and there's a lot of people who use that data. So the particular application that the modeling team is looking for might be different than maybe the inspections or the compliance team. So there's that also, that there's a number of different users that might want different sets. I can't give you the details on the fail tags. I'm not sure. I just know it's taking too long. And I'm diving into it. So I know we had a question back here, the gentleman. Didn't want to miss him.
Online first.
Oh, whatever. We'll go online and then we'll come here. Right?
All right, from online, we have a question. Is there a plan to deploy electric meters with edge computing capability to assess momentary faults below the threshold of protective equipment that can signal foliage impingement on power lines?
Yeah, that's a great question. So I think that's definitely an area for improvement. I will say today we utilize the smart meter network to detect partial voltage conditions. So kind of one of the unique challenges of the California distribution system is it has a high predominant amount of 3-wired distribution. That means in common terms, we don't run a neutral with those 3 conductors. And when we have a fault occur where only one of the fuses on the power line operates, we can have a partial voltage condition. And it's a very difficult situation to detect with protective relaying. So we're actually leveraging the AMI infrastructure network to send us a message back that we have a partial voltage situation, so that we can then take operator intervention to actually de-energize that section of the circuit proactively in case there is a high impedance fault or a wire on the ground that's undetectable by our relaying strategy. So that's one example of how we're using smart meter data to provide this enhanced level of protection on our system. I think to the question online, there's definitely more use cases to leverage that information. They're a great resource of sensing on our system, and I would definitely recommend relaying more innovation around the AMI network.
One more online question. How do we currently optimize truck rolls for secondary inspections? Are we using data to optimize this? Are you aware of how SDG&E is managing this? And do you use machine learning models to make meaning of LiDAR and other data?
There were a lot of questions in there. So the risk models I referred to, they do use machine learning models, and LiDAR is one data set of many that is used as part of that ingestion process to produce that result. As for the truck rolls, what was the question again?
How do you optimize truck rolls for secondary inspections? Are we using data to inform how to do inspections?
So for inspections, for inspections or work, you tend to try to group all the work, right? Because sometimes it feels like the most expensive part of something is just rolling a crew out to a location. And so you try to group the work into their work packages for that day, whether it be inspections or closing tags or whatever it might be. The gentleman here in the center table has hand up. I want to make sure we get. Yeah, right here.
Thank you. Frank Freevault with Cal Poly Wildfire Institute. There's a lot of work, obviously, that you're looking to put into this. Can you talk a little bit about the things that you use to prioritize that work, the sequence you'll go into it?
Do that. I will point out that there's an integrated grid planning session going on right now in another room, but I'm related to that too, so I can answer your question. So we call that integrated grid planning. So there's prioritization that happens within each work group, if you will. So for example, like pole replacement, you say, hey, let's look at all the poles. Let's try to identify which ones to replace first. Again, trying to get at, okay, we know somewhat of their condition. For the best grid performance, which poles should we replace right now? And you look at either wildfire risk or public safety or reliability concerns around that. Once you've prioritized within those individual groups, then you got to bring it together and say, okay, let's build our budget. What are we going to do with the budget we have? Should we do more on poles? Should we do more on transformers? Should we trim more trees? That's where you do that balancing. That's called integrated grid planning. We try to do that based upon the assessment of risk and risk reduction, so the benefit from each one of those. So that's kind of that process. We call it integrated grid planning.
Is there a piece of that looks at proximity to communities?
Yes, on several levels. Your reliability assessments, if a pole is impacting more people, then that tends to be closer to people. But then the public safety portion of it also, because we're looking at what's the potential impact of something failing and causing a problem to somebody, a car or a person walking in the vicinity at the time it fails. Great question.
Hi, I'm Anukul from BurnBot. I was wondering if you could comment about what data you're collecting with respect to measuring surface fuels. So specifically the flashy, fine fuels that, with all the rains that we've seen create ignition risk. So I understand that LiDAR is really effective for looking at tree densities and number of trees, but measuring surface fuels like shrubs and grass that's drying up.
It's a great area for discussion. I'm gonna have to borrow my meteorology hat, which I'm not. This is an area for some improvement. We've talked to several groups prior to today's event on getting better data at this. Right now, when you do your assessments of your fuels, whether they be, we call them 10-hour fuels or 100-hour fuels, right? Often they're based upon what we call antecedent conditions, meaning, hey, I know this area got so many inches of rain. And I know it tends to be maybe a herbaceous or whatever type of fuel base, right, in that area. You take those two things combined, and then you calculate your your fuel or your vapor pressure kind of things. I think there's opportunity to move from an antecedent type of an approach to maybe a more direct measuring. But other than that, you're going out and you're clipping leaves and you're, putting them in an oven kind of a thing. So. Okay, who's going to help me manage? Oh, we need
Online
to go back
question
to the
over here.
online. Okay.
Yeah. Has PG&E considered leveraging low latency private LTE wireless broadband in conjunction with Schweitzer Engineering Lab's falling conductor application to de-energize conductors before they contact the ground? SDG&E is implementing this technology.
Yeah, I'll take that one. So I am very aware of the pilot with SDG&E and SCL. One thing I would say that, just in transparency, that's a challenge with some of the areas of our territory is there's definitely no line of sight in especially the forested areas. And in those areas, there's also challenge even getting LTE reception. So some of the challenges, for example, in San Diego and even in Southern California, from a topographic standpoint, are quite a bit different than where we see the highest risk in the Sierras and in the foothill. That said, I think there are still areas that we could look at implementing these types of communication systems. As I mentioned earlier, running fiber, running high bandwidth communication schemes to the different parts of our distribution system has to be part of the solution for achieving the really fast protection clearing times that we need to reduce the ignition risk, as well as setting up these blocking schemes so that if a problem does happen beyond a certain protected device, we limit the outage to as few customers as possible. So I would say, yeah, in general, we definitely need to see communication schemes integrated with our protection systems. But some of the topographical challenges of our territory, especially in the Sierras, makes it a very complicated problem. I think even a little bit more so than what's seen in San Diego.
And one more online question. Why deploy any vegetation management if novel protection methods like EPSS can quickly de-energize lines and eliminate ignitions? How do you think about deploying the right balance of vegetation management and EPSS?
That's a great question. So, we have success with our enhanced power line safety settings. It's demonstrated through the reduction in reportable ignitions. However, there are still ignitions occurring, and in order to combat this threat on our system, we have to look at all our options. Vegetation management will continue to be a core component of reducing wildfire ignition risk on our system. As we layer on additional strategies such as enhanced power line safety settings, such as undergrounding, such as the fuel clearing methods, like was mentioned with BurnBot, all these things together will provide a defense in depth strategy to reduce our ignition likelihood. I'll be the first one to admit no one solution is perfect, but we've taken the approach where at all possible we try to layer on all the approaches on top of each other to have the highest success of reducing the ignition. Right, Drew?
Well, while we're bringing that mic, I want to point out though, on that question on vegetation, there's still a compliance requirement that we keep other objects away from the lines a certain distance. There'll always be a component of vegetation management. Go ahead and bring the mic in, sorry.
Thank you. You talked about the line sensors, what have you, and I want to ask you a question whether you have already piloted or experimented with, there's existing line sensor providers. You can get very granular readings, like 30, 60 reads per cycle. So are you leveraging those existing technology, like provided by, they can measure phases, right? So you can almost plot out a waveform for your every line and find transient faults. So the providers are Togates, Sentiens, and those guys. And I mean, they exist. What's your thoughts on that?
Yeah, we've implemented both manufacturers cited for line sensors. I think the innovation area for line sensors and in general, all of our protective relaying that has the capability of logging electrical events is to have an automated system that can decipher and distinguish the different types of events that you can measure and observe on the system. Some disturbances are so small and subtle and short that aren't necessarily indicative of a imminent failure of a component of the system or an ignition risk event. But then some do have that signature. So having AI or having automation around processing these signals, as was mentioned, very high sampling rates from all the different types of devices, relays, line sensors, is kind of the challenge that we see right now needing to be solved. We have a lot of data. There's a lot of edge devices that can send us information. We just don't have enough engineers necessarily to pour over all that data. We need automated methods to categorize and rank in highest priority. That question. Time to here. Okay, a little bit of time.
Noah Carr with Rock Robotics. You guys discussed LiDAR data taking a very long time to get to you. When you guys collect that data or looking at that data, do you guys think about doing smaller batch collection in terms of quicker turnaround time? Is that something that you guys are more interested in? Or do you guys typically just do large runs where the data amount is quite significant?
I think it's kind of a combination of both. They're processing it in batches. That as an end user, I kind of need all of it to build a model that represents the whole system. So that's the perspective of one user. There may be other users like, okay, that's great. I can take it in small chunks too. Yeah, we use a number of different sources, satellite, even synthetic, what we call synthetic LiDAR, like satellite informed models to give us something similar. We're looking at a variety of different areas like that, but I put that out there as an example of this type of data. We talked about speed, right? The speed at which we can ingest that and use that. Even data that was 6 months ago, trees are going to grow in the interim, or we may have done work in an area and I'd like to see that show up in the data that work was done last month or less. So this idea of speed is wasn't trying to dish on LiDAR necessarily. We love that type of data, but it's the speed component of it.
A couple online questions
Okay,
here.
and then we got.
I think one of you spoke about this earlier. How are we handling the application of wildfire mitigation technology in areas that have limited cellular and GPS coverage, which are some of the higher risk areas? Which technologies are we looking at?
Yeah, we've talked on this a little bit in terms of communication schemes. Satellite communication is an option. We do have capability to deploy, and we have the capability of installing repeaters. If, for example, a device is needed where there's a lot of overgrowth of the forest, we can try to get out to a clearing, provide that level of communication. Yeah, a fiber deployment. The question was, are we looking at fiber as part of our wildfire mitigation strategy? The answer is yes. We do need to look at including that, I think, into the underground program. Especially as we work the underground program, there's different areas of the circuits that we're targeting, not necessarily the entire circuit at once. So there's an opportunity to install communications equipment for not only the communities that we're serving for broadband and whatnot, or providing access to telecommunications providers to join into the trench, for example, but also to provide our own communications network to be able to implement some of these more sophisticated protection schemes.
Is the mobile mic working? I know we can hear each other in the room, but there's a lot of people calling in, so I want to make sure we use the mic for the questions. The gentleman here.
Yes, my name is Sean Donegan. I own a company called Satellytics. You talk about risk reduction. I've been a couple of questions around the room about LiDAR. LiDAR will always be slow in its turnaround time, but the use of stereo pair satellite data at a very high spatial resolution, you know, you get the results within 3 or 4 hours, literally. So to process risk, if you had more and more data that was very specific rather than lots of engineers poring over it, most of it's using, you know, like convolutional neural network at the heart of it. So you'd get just the results where you would have to take action on. And I think that is a very, plus you're not deploying physical hardware that you then have to maintain, you know, and in today's world, you could be looking every day if you wanted. Of course, you've got to do the risk reward balance to that. But in terms of reducing risk, and that could be looking at the fire on the floor, you know, the grasses down to grasses. It could be looking at trees and extended limbs and the other elements, including third-party encroachments on both distribution and transmission networks.
Great comment. Lots of area for improvement there. I agree. I know we've got the 5 minutes, so I want to make sure we get questions. Our goal is to try to give you information and have a conversation that sets you up for the next stage, right? That was described this morning. I think there's one more question here. And then.
Richard Weiss, Guru Wireless. You mentioned you'd like to, you do inspections, and you mentioned annually and maybe over 6 months, and changes occur during that time. If you had your druthers, would you have continuous monitoring, and what are the impediments to doing that?
So there's compliance inspections, which is kind of like, that's our requirements. But when we start thinking about what's the purpose of inspections, is it if we decide our purpose is to detect something before it fails, then the frequency we're talking about or the cadence is we're wide open. The limitation is really how fast can we ingest and process and take action. Because if I'm getting an update every week, but my process to ingest, identify, and send out a crew takes 4 months, that's not helpful, right? So I don't want to limit how frequent we are. There's also improvement for how, that's why we talked about the ingestion process and the work identification and all that entire process is linked together. But if we want to get to a grid where we're responding quicker, then there's need for improvement in all these areas. It was a great point. I think we have another question here on this next table.
Thank you. Gilbert Asal with Wildfire. So data analysis and visualization is always a problem when you're integrating different data sets. I think this is more of a comment, but one of the things that'd be helpful is to get a framework similar to the one that you've provided so far for how you want to visualize the data and what you've seen is actually helpful for you to visualize the data as a user or as a customer.
So your point is it'd be good to understand
how you want it,
how we want it, and kind of how we put things together. Because I know one of the biggest challenges, you got all these different data sets and how do you correlate them or connect them,
exactly
right?
how you want it. What have you seen that works well in the past, and what was missing from those examples, so that we can, so industry can help you fill those gaps in a more effective way. Because that's one of the lines that I think would be most helpful to establish with the community as a whole is how do you want the data integrated?
That's a great point for us, and it's a great point for just, I think, the industry in general, even cross-regulatory and industry participants in modeling. A good point. Okay, I'm getting a last question and then a wrap up. No one's doing this, so.
I've got an online question
All right,
here.
more online.
For continuous asset and hazard monitoring, what resolution satellite imagery or I think it's synthetic aperture radar data does PG&E require for risk modeling and mitigation? What resolution?
Right now, we require the best we can get. We're down to about 3 meters, and we're talking to people who are talking about sub-meter level. but I think that's kind of just where the industry is at on that too. So great question. Thanks for your questions. Thanks for your interest. We really hope to talk to you more about these areas and make them a reality. So thank you.
Thank you.